Alright, this is Colby and Aiden, and our project was Bayesian Dark Knowledge. So what we were trying to do is use this census data from 1994 to predict whether a person made $50,000, more than that or less than that. And if you were to go about this in a strictly Bayesian way, we would have a prior and then input this data, and then using that data, it would update the prior, giving the posterior. So this would be kind of this process of doing a Bayesian crank, essentially. But another regime that also has this process is machine learning and neural networks, where you have these networks which are generic models, but as you feed them more and more data, iteratively updating the model gives you better predictions, so you're generally just going to optimize this prediction through the neural network. So what we're trying to do and what this paper does is combine these two ideas together.
So specifically, when using a neural network, the neural network has a set of parameters, which we denote with theta. And then, like Aiden said, the neural network, using the data, will optimize the parameters. So from a Bayesian perspective, what we're simply trying to do is compute the posterior distribution of theta given our data, which is in green at the top there. And then from there, we want to find the posterior predictive distribution, which will allow us, given some x that is not in our data set, we can predict the y, which would be whether that person made more or less than $50,000. And what this paper shows is how you can essentially approximate these distributions like we would have done with MCMC or JAGs using neural networks, and they show how you can do that in a very efficient way, a much more efficient way than had been done in the past.
So we ended up getting our model to run. Our final results were about an accuracy of 75-ish%. So that means that out of every 100 guesses, or 100 X inputs, 75 of them would give the correct output. So the Bayesian paper focuses more on other methods of describing efficiency, but we were just happy to get it to run and to get reasonably good estimates.